Okay, I'm skipping to number 10 because we did number 7 and 8 as part of our jigsaw, and we did number 9 as our warm-up. So number 10, skipping to number 10. Now this one is interesting because sine x over cosine x, if you look at our formula packet, you might recall that this is one of our trig relationships. Sine over cosine is the same thing as tangent. So what we're actually doing in this problem is we're actually finding out what is the derivative of tangent of x. We are going to discover the derivative of tangent of x because sine over cosine is the same thing as tangent, right? So we learned this in our unit circle. Something else interesting here, now that we're looking at it, is remember our identities. This one is our most important one. Cosine squared plus sine squared equals 1. That comes from the Pythagorean theorem. And we can get that also directly off of our unit circle. These two ones we didn't actually teach in class. It was an extra credit problem on the final exam. And if at some point we have time to go back and talk about them, we will. But if you happen to have a trig problem and you're trying to simplify it and things are getting crazy, you can just look and see, oh, is there any substitution I can do using any of these rules? So don't worry, for this packet that we're working on, you do not need these. But I did want to point out that we are about to derive the derivative of tangent. Okay, so if we look over here, derivative of sine, derivative of cosine, look, it gives us the derivative of tangent. It says the derivative of tangent is 1 over cosine squared x. So that is what we're actually proving. We're actually proving that the derivative of tangent is 1 over cosine squared x. That's why this problem is on here. So we can discover where that derivative comes from. All right, so we're going to actually not do anything with this tangent. I'm just pointing it out that f of x equaling sine over cosine is the same thing as f of x equaling tangent of x. So we're going to use the quotient rule to solve this. So our quotient rule, we need to set up our u and our v. Our u is the numerator, our v is the denominator, and then we're going to type the derivative of each. So again, referring to our formula packet, the derivative of sine is cosine. The derivative of cosine is negative sine. Now we're going to crisscross applesauce, but the order is important. You have to start with the v. So my f prime of x is equal to v times u prime. So cosine x times cosine x minus u times v prime, sine x times negative sine x. And then all divided by v squared. So cosine of x squared. Now, notice how close we are to this. We already have the denominator, because another way of writing cosine x squared is to just write it as cosine squared x. That means the same thing. Now, on top, what's another way of writing cosine x times cosine x? Cosine squared x. Okay, and then notice here I have a negative times a negative. Negative times a negative becomes a positive. Okay, that's like having a negative 1 there. Negative 1 times negative 1. Okay, I can do a same change kind of thing. Negative times a negative is a positive. So this is going to become plus sine x times sine x. Oh, sine squared x. Hey, that should look familiar. Cosine squared times sine squared. If we go back and look, isn't that what we were just noticing? Aha! It equals 1. Cosine squared plus sine squared is equal to 1. That comes from our Pythagorean theorem. So now I can just simplify this. This is 1 over cosine squared x, and then I have my answer. All right, now it wants me to find the second derivative, so all we got to do now is take this, our 1 over cosine squared x, and take the derivative. So I'm going to rewrite this as cosine x in parentheses squared. I think that's going to be helpful for doing this. So I could use the quotient rule again, or I could rewrite it, moving this up to the top with a negative exponent. So there's actually two ways we can do it. Let me see, how did I actually do it when I did it? I went ahead and I did not use the quotient rule. I used the chain rule. I'm kind of curious. What happens if I use the quotient rule? I'm going to go ahead and use the quotient rule. So, well, actually, this isn't a function, right? 1 isn't really a function. U is equal to 1. That's going to simplify to 0. Now I'm kind of curious. Maybe I will do it both ways. So what if we do the quotient rule? So if we do the quotient rule, U is equal to 1. So therefore, U prime is equal to 0. V is equal to cosine x squared. So to do that, I got to use the chain rule. I'm going to bring down 2 in front of cosine x minus 1 from that, times the derivative of this. The derivative of cosine is negative sine. Okay? And then I crisscross applesauce. And so it would be this one times this one would go first, which is just 0. 0 times cosine squared x minus this one times this one. So that would be 1 times 2 cosine x times negative sine, forgot my x, all divided by what am I doing? V. Cosine x squared. So this just goes to 0. Here I have a negative times a negative. So that would give me, that would give me negative times a negative. Those go with, so I'd have 2 cosine x sine x over cosine x squared. Oh, this is interesting. I'm getting a different answer than I got before when I did it the other way. Wonder if what did I do? Because I did it both with the chain rule and without the chain rule, and I'm getting a different answer. Okay, so anyway, I could simplify this, and I would get 2 times sine x over cosine x. So I could get that, and now I'm looking at, how did I do this before? I think I made a mistake somewhere. Okay, so I'm getting that for my second derivative. F double prime of x is equal to 2 times sine of x over cosine x. But I'm kind of thinking maybe I made a mistake, because I also did it with a chain rule and I got a totally different answer. So I'm going to take a break for a second and see if I can straighten this out.